Purpose of design. Solar drones are defined as drones that use solar cell power directly from the sun that will fly in the air for a long period. Maximum flying time of a regular drone is approximately 25 to 30 minutes. US-1 is a drone that has the longest battery life, which is approximately lasted 2 hours. With this design, we can run longer time than 2 hours. It's going to rely more on the energy from the sun rather than battery. Utilizing solar energy to power a drone to reduce the need for drones to return to their base for charging. Why solar cells? A drone battery is about $50 to $150 depending on the brand of the drone. Average lifespan of battery is between 4 to 6 years. The average cost in Las Vegas would be $80 to charge a drone. 12-volt 100-watt solar panel with amp charge control is about $150. Average lifespan of a solar cell is between 25 to 30 years. A single solar cell can cost about $5. Methods. Solar cells to generate power. Image shown on the right are the solar cells connected in such a way so that the generated energy will provide the efficient power. One solar cell provides 5 volt, 30 milliamps, 0.15 watt. Control setup. Image shown on the right consists of electronic speed controller, Arduino, and motor propeller. Due to the configured setting, the entire drone was not used in this project. A control setup is needed in order to adjust the speed of the motor propeller. Power control. Image shown on the right is the circuit implemented in order to switch between battery and solar cells energy. The circuit will operate when power is lower than the battery power to maintain flying time of the drone. Design. Solar cells concept. Solar cells are assembled and connected 40 cells in series and 4 in parallel. Each solar cells provide 5 volt, 30 amps, and with the assembled solar cells, it provides 20 volt, 1.2 amps, 24 watt. By generating 24 watt, the motor and propeller works at speed on a clear sky. The video taken shows the process of development for the design. Results. The process of having 4 motors with the solar cell energy was calculated and tested with the minimum solar cells. The total number of solar cells used is 160 individual solar cells. Processing the current drop through the switching circuit and the control circuit that contains the Arduino, motors and propellers run in half speed. This is the result when we have a clear sky and no cloud blockage. Having a clear sky, the generating process will contain more power from the sunlight. The video to the right shows 4 motors working with only solar cell. The slow motion of the propeller is due to slower shutter release lag. The propellers are moving faster than required. In conclusion, with this design, we can run a drone for a long period of time at a lower cost. The type of solar cells we use, the speed controller, and the Arduino affects the project's performance. This project's main component is the switching circuit. The drone's energy and flight time are extended by alternating between the battery and solar cells energy. The solar energy used to power the drone is renewable as well, which means less money powering the drone. The video to the left shows the complete setup of motor, speed controllers, Arduino, switching circuit. The theory that a drone can be run on a solar power is proven. The video below shows 2 motors running with a solar power and the circuit in which switches provided power when the drone is under the shade. As you can see, we're running on solar energy, and at the same time LED is on, indicating that we're charging the battery. As we move on to the shade, the propeller is still running. Our LED went off, meaning that we're not charging the battery, we're running on battery. As we move back to the sunlight, solar energy takes over.